Hare Krishna. Dear student, again I am myself a Patil madam. In the last video, we have studied about the formulas of the derivative. We have studied all the algebraic, trigonometric, exponential and the logarithmic formulas, and we have proved all the formulas with the help of a first principle of derivative. Now the application of the formulas here. Now we have to study the rules of the derivative. How will you apply that formula and what are the rules of the derivative? Now if there is an addition of a two or more than two function, how will you find out the derivative? The first rule, suppose the function there is a addition of a two function, the rules of derivative. See the rules of derivative. The first rule, if there is an addition of two function u plus v, then how will you find out the derivative? You have to take the derivative of a first function, that is u, plus then you have to take the derivative of a second function v, isn't it? Suppose more than two functions are added, then you have to take the derivative one by one, isn't it? So many n functions are added, then you have to take the derivative of every function. दोन किंवा दोनपेक्षा अधिक टर्म्सचं ॲडिशन असेल तर प्रत्येक टर्मची आपल्याला डेरिव्हेटिव्ह घ्यावी लागेल. नाउ हियर ddx of u plus ddx of v. Now suppose there is an extension, that is u1 plus u2 plus u3 up to un. Then again, how will you find out the derivative? ddx of u1 plus du2 divided by ddx of u3. Here again, ddx of u3 dash 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 ddx of un, n function. Suppose the n functions are added, then you have to take the derivative of a functions one by one. Now there is a subtraction of a function, same here, u minus v. Again you have to take the derivative of a u and minus derivative of a v, isn't it? Again suppose there is an extension, that is u minus v minus w, like this. Again ddx of u minus ddx of v minus ddx of w, right? In this way you can make the extension. The fourth rule, suppose there is a product of a two function uv. If the two functions are multiplied, if there is a product of a two function, how will you find out the derivative? See, this is the very important rule. First, function remain as it is. पहिलं फंक्शन जसंच्या तसं ठेवा. याच्यापैकी फर्स्ट फंक्शन यू कॅन कन्सिडर u as well as the v. कुठलेही फंक्शन तुम्ही फर्स्ट फंक्शन म्हणून कन्सिडर करू शकता. सो u remain as it is, take the derivative of a v plus v remain as it is, take the derivative of a u. Or you can say v remain as it is, take the derivative of a u plus u remain as it is, take the derivative of a v. कसे लिहू शकता तुम्ही? हे दोन फंक्शन जर ॲड असेल तर इथे काही कंपल्सरी नाही की पहिलीच टर्म आधी घ्यायची नंतरच दुसरी घ्यायची, असं काही नाही. फर्स्ट फंक्शन वन फंक्शन यू रिमेन ॲज इट इज, टेक द डेरिव्हेटिव्ह ऑफ अनदर फंक्शन प्लस द अनदर फंक्शन रिमेन ॲज इट इज अँड देन टेक द डेरिव्हेटिव्ह ऑफ ए फर्स्ट फंक्शन. नो हियर suppose there is an extension, there is a multiplication of a three functions u v w, isn't it? Then what you have to do, first two function remain as it is, u v remain as it is, take the derivative of a w plus v w remain as it is, take the derivative of a u plus again u and w remain as it is, take the derivative of a v. Therefore first two function remain as it is, uv constant, these two function remain as it is, take the derivative of a w plus you have to give the plus sign. Again vw remain as it is, vw remain as it is, take the derivative of a u. Again plus uw remain as it is, uw remain as it is, take the derivative of a v, right? Now this rule you can write like this. हा रूल तुम्ही असा पण लिहू शकता. See here, that is u v w. This three function multiplied. Here you can write 1 upon u du divided by dx, 1 upon v dv by dx, 1 upon w dw divided by dx. Now if you observe this, see here, if you observe this and if you multiply this UVW with this first term, you get cancel, you will get VW into du by dx. Here VW into du by dx, the middle term you have got. Suppose you multiplied with UVW to 1 by V, VV get cancel, again you will get UW into dV by dx. Here UW into dV by dx, the third term you have got. Again UVW into 1 by W, WW get cancel, again you will get UV into dW divided by dx, the first term you have got, right? Therefore this theorem or this rule you can apply like this. Whenever there is a product of three functions, first you can keep UV as it is, take the derivative of a W, then plus you have to give the sign, VW remain as it is, take the derivative of a U, plus UW remain as it is, take the derivative of a V. Otherwise UVW you can write as it is, again 1 by U remain as it is, take the derivative of a U, plus 1 by V remain as it is, take the derivative of a V, again 1 by W remain as it is, take the derivative of a W, isn't it? In this way also you can apply the rule. Similarly, there is a multiplication of a three functions, the product of a three functions. Suppose there is an extension, right? Suppose see here ddx of u1, u2, u3 and up to un. Then what can you do? How will you write this here? See, u1, u2 dash dash un remain as it is, in the bracket 1 upon u1, take the derivative of u1. 1 upon u2 remain as it is, take the derivative of u2. Plus 1 upon u3 remain as it is, take the derivative of u3. Dash 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 again 1 upon un, take the derivative of un. Right? In this way you can apply the rules of the derivative for the product of a n function also, isn't it? These rules are very very important here. Again the seventh one, ddx of u by v means there is a quotient of a two function or the division of a two function. What you have to do? Again this rule, it is very very important. Again the denominator remain as it is. Here you have to strictly put the denominator remain as it is. हे मिटवून टाकते ना एकदा. स्टार्ट केलं. If there is a quotient of a two function, that is the division of a two function, how will you find out the derivative? First you have to keep the denominator remain as it is, v remain as it is, take the derivative of a numerator, that is du divided by dx. Strictly here you have to put the denominator remain as it is, right? The denominator remain as it is, take the derivative of a numerator minus numerator remain as it is, take the derivative of a denominator and divided by denominator square, where v should not be equal to 0, right? Then and only then you can find out the derivative if there is a quotient of a two function or the division of a two function. It's again very important. In the division of a two function, denominator remain as it is, take the derivative of a numerator minus numerator remain as it is, take the derivative of a denominator divided by denominator square. तर या क्वोशंट रूलमध्ये पहिल्यांदा काय करायचं आहे, डिनॉमिनेटर जसाच्या तसा ठेवा, टेक द डेरिव्हेटिव्ह ऑफ ए न्यूमरेटर, u चे डेरिव्हेटिव्ह घ्या मायनस न्यूमरेटर रिमेन ॲज इट इज, देन टेक द डेरिव्हेटिव्ह ऑफ ए डिनॉमिनेटर, डिनॉमिनेटरचे डेरिव्हेटिव्ह घ्या डिवायडेड बाय डिनॉमिनेटर स्क्वेअर. Isn't it? Now here again eighth one, ddx of k divided by v. Again the same division rule, but here this k it is a constant and here u it is the function. See how will you work this division rule here. Again v remain as it is, take the derivative of a k minus k remain as it is, take the derivative of a v, isn't it, divided by v square, right? Again if you observe this, v remain as it is, but the derivative of a constant function it is always equal to 0, therefore this is 0, minus k remain as it is, and the ddx of v remain as it is, dv by dx, and divided by v square. Therefore, here you have got v into 0, 0, minus k divided by v square into dv divided by dx. Right? Means whenever there is a constant in the numerator and the function it is in the denominator, the constant remain as it is, give the minus sign, make the square of a denominator and take the derivative of a denominator, minus k divided by v square into dv divided by dx. How will you work this formula? That is, k remain as it is. Here you have to give the minus sign, take the square of a denominator, that is v square, and into take the derivative of a denominator. In this way, you can apply this rule, that is the division rule, isn't it? Now here the last here, that is ninth one, see, ddx of k into f of x. Again, there is a multiplication of a two function, right? K into f of x. K is the constant and f of x is the function. Again, you have to apply the product rule, that is k remain as it is. Take the derivative of a f of x plus f of x remain as it is. Take the derivative of a k. Right? Again, k remain as it is. What is the derivative of a ddx of f of x? I have given already the notation, that is this you can write as a f dash x. Again, f of x remain as it is, and ddx of constant, that is always equal to 0. Therefore, here k into f dash x and f of x into 0, that is 0. Means what is actual the application here? See, whenever the constant it is multiplied to the function, constant remain as it is, take the derivative of a function. And the derivative of a simple constant function, आणि नुसता जर कॉन्स्टंट असेल तर त्याची डेरिव्हेटिव्ह काय येतो 0. पण तोच कॉन्स्टंट जर फंक्शनला मल्टिप्लाय होत असेल तर कॉन्स्टंट रिमेन ॲज इट इज, टेक द डेरिव्हेटिव्ह ऑफ ए फंक्शन. फॉर एक्झाम्पल, सपोज ddx ऑफ k into 5 into sin x. Right? Don't say 5, 0, right? 5 remain as it is, because the 5 it is multiplied to the sin x. When the constant it is multiplied to the function, constant remain as it is, take the derivative of a function, ddx of a sin x, means 5 remain as it is, ddx of sin x, that is equal to cos x. Right? So these are the rule of the derivative. So in the rule of a derivative, what you have to remember, if there is an addition of a two or more than two function, then you have to take the derivative of a every function. If there is a subtraction of a so many function, again you have to take the derivative separately of each function. If there is a product of a two function, in the product of a two function, first function remain as it is, take the derivative of another function, plus another function remain as it is, and take the derivative of a first function, that is u into v, isn't it? Product rule, again it is very very important. Here, whenever there is a product of a two function, then first function remain as it is, take the derivative of another function, plus another function remain as it is, take the derivative of a first function. If there is a product of a three function, then what you have to do? I have told you directly the rule here. First two function remain as it is, take the derivative of a third function, plus then second and third function remain as it is, take the derivative of a first function, plus first and third function remain as it is, take the derivative of a middle function. Right? And another rule also I have told you, that is first you have to write u v w, then the first 1 upon u remain as it is, du by dx, plus 1 upon v remain as it is, dv by dx, plus 1 upon w remain as it is, dw divided by dx. In this way also you can apply that formula, isn't it? Now the quotient rule, again it is very important. If there is a division of a two function, then denominator remain as it is. First you have to keep the denominator remain as it is, take the derivative of a numerator, minus numerator remain as it is, take the derivative of a denominator and divided by denominator square. Right? This rule little bit complicated. First here the denominator remain as it is, take the derivative of a numerator, minus numerator remain as it is, take the derivative of a denominator divided by denominator square. Again, when the constant it is multiplied, and here in the denominator there is a function, that is k by v, the directly you can use this formula, minus k divided by v square, and you have to take the derivative of a denominator, that is dv divided by dx, isn't it? So these are the rules about the derivative. Again the last here, when the constant it is multiplied to the function, constant remain as it is, take the derivative of a function. This is also very very important, and the derivative of a constant function, it is always equal to 0, right? Now I will take here, suppose there is an addition of a two function. See the first example, very simple. Say, suppose I have added the function like this. The first here, and the first formula, that is our first formula, see here, ddx of x to the power n. What is the derivative? N into x to the power n minus 1. Suppose I take the example, simple example. पहिले याच्यावरचे example घेऊ आपण या फॉर्म्युल्यावरचे. ddx of x, ddx of x square, ddx of x to the power 5. Fourth, ddx of x to the power 10. Fifth, ddx of x to the power 4 by 3. ddx of x to the power 5 by 4. ddx of x to the power 2 by 3. Eighth, ddx of x to the power 7 by 8. Now see, it's very simple. X चे derivative मी already सांगितले, that is equal to 1. X square, what you have to do? Here you have to multiply the power and you have to subtract 1 from the power of x. Here, what is the power? 2. X into x to the power 2 minus 1, isn't it? You have to subtract 1 from the power 2 minus 1, means 2 into x, because 2 minus 1, 1, isn't it? Again, 5, power it is multiplied, x to the power 5 minus 1, 4, very simple. 10, x to the power 10 minus 1, 9. Again, 4 by 3, what is the power? 4 by 3. x to the power 4 by 3 minus 1. जेव्हा आपल्याला 1 सबट्रॅक्ट करायचं आहे कशामधनं? फ्रॅक्शनमधनं. Whenever you have to subtract 1 from the fraction, a simple way, you have to subtract 3 from 4. हा डिनॉमिनेटर न्यूमरेटरमधून मायनस करून टाकायचा. 4 minus 3, 1, आणि इथे लिहायचं 1 divided by 3. हा डिनॉमिनेटर जसाच्या तसा. व्हेरी सिम्पल. वेनेवर यू हॅव टू सबट्रॅक्ट 1 फ्रॉम द फ्रॅक्शन. केव्हा आहे? जेव्हा तुम्हाला 1, फक्त 1 बरं का, 1 जर फ्रॅक्शनमधून सबट्रॅक्ट करायचं असेल तर आता इथे बघा 4 divided by 3 minus 1, तर 4 minus 3 करून टाकायचं. 4 minus 3 किती? 1, and 3, this denominator remain as it is. आता इथे बघा 5 by 4, राईट. अगेन x to the power काय करायचं? 5 minus 4, अगेन 1, 1 by 4. व्हेरी सिम्पल. अगेन हिअर what is the power? 2 by 3. 2 by 3 x to the power 2 minus 3. काय करायचं? 2 minus 3. 2 minus 3 means minus 1 by 3. Isn't it? Again, power it is multiplied 7 by 8. X to the power 7 minus 8 करा. 7 minus 8 means minus 1 by 8. It's very simple. This is the problem on first formula, that is the power formula. What is the power formula? x to the power n, याची डेरिव्हेटिव्ह काय येतं? n into x to the power n minus 1. Here the power it is multiplied आणि xच्या पॉवरमधनं आपण काय करतोय? 1 सबट्रॅक्ट करतोय. सो रिमेंबर दिस व्हेरी व्हेरी इम्पॉर्टंट फॉर्म्युला. आपण जेव्हा प्रॉब्लेममध्ये हे देतो, म्हणजे हा फॉर्म्युला अप्लाय करतो, तेव्हा मुलं प्रॉब्लेम करतानाच चुकतात. तर हा पक्का लक्षात ठेवा. इथे आपण पॉवर मल्टिप्लाय करतो आणि एक्सच्या पॉवरमधनं x सबट्रॅक्ट करतो. Right? Here, what is the power? 1. 1, x to the power 1 minus 1 means 0. So, the derivative of x, it is always equal to 1. Remember, the derivative of x, it is always equal to 1. X square, 2 into x to the power 2 minus 1. 2 minus 1 means 1, means the power of x, that is equal to 1, 2x. X to the power 5, 5x to the power 4. Power multiplied, and power madna x subtract. X to the power 10, 10 into x to the power 9. x to the power 4 by 3, 4 by 3 x to the power. फ्रॅक्शनमधनं एक सबट्रॅक्ट करताना काय सांगितलं मी? न्यूमरेटरमधनं डिनॉमिनेटर सबट्रॅक्ट करा. 4 minus 3, 1, 1 by 3 लिहून टाकायचं. अगेन एक्स टू द पॉवर 5/4, 5/4, एक्स टू द पॉवर 5 - 4 करा, किती 1/4. अगेन एक्स टू द पॉवर 2/3, 2/3, एक्स टू द पॉवर 2 - 3 दॅट इज इक्वल टू 1 - 1/3. अगेन एक्स टू द पॉवर 7/8, अगेन 7/8, एक्स टू द पॉवर 7 - 8 करा, 7 - 8 अगेन -1. Right? This is the first power formula. It's again very very important. Right? Again the last here, that is the power. समजा डिनॉमिनेटरमध्ये असेल तर काय सांगितलं होतं मी तुम्हाला, हिअर -n डिवायडेड बाय एक्स टू द पॉवर n+1. इथे काय करायचं आहे, पहिल्या याच्यात पॉवर मल्टिप्लाय करत होता, पॉवरमधनं एक सबट्रॅक्ट करत होतं. आता इथे काय करतो आहे, पॉवर मल्टिप्लाय करतो आहे पण मायनस चिन्ह देतो आहे, -n. जर डिनॉमिनेटरमध्ये पॉवर असेल तर -n डिव्हायडेड बाय एक्स टू द पॉवर n+1 या पॉवरमध्ये एक मिळवायचं आहे आपल्याला. राईट? आता सिम्पल एक्झाम्पल सी आहे. फर्स्ट 1/x ddx ऑफ 1/x. चला, व्हॉट इज द पॉवर 1 मीन्स -1 डिवायडेड बाय एक्स टू द पॉवर. Again n is equal to 1, 1 + 1 2, right? Means the derivative of a 1/x, that is always equal to -1/x². Simple. ddx of 1/x². Tell me, -2 divided by x to the power 3. Again ddx of x to the power 5. Again -n means -5 divided by 1 added 6/4. ddx of 1/x to the power 13. Again -13 divided by x to the power 14. Again fifth, ddx of 1/x to the power 20. Again -n means -20 divided by x to the power 20 + 1, that is equal to 21. If there is a fraction, power same. Again 6 ddx of 1/x to the power 4/3. See here, the power is fraction, then what you have to do, -n means -4/3, x to the power n+1 means 4/3 + 1. आता जेव्हा फ्रॅक्शनमध्ये 1 ॲड करायचं आहे, काय करायचं आहे, 1 ॲड करायचं आहे, तेव्हा काय करायचं आहे, या पॉवरमध्ये दॅट इज या न्यूमरेटरमध्ये डिनॉमिनेटर ॲड करून टाका. 4 + 3 किती 7, 7 लिहायचं 7/3. व्हेरी सिम्पल. सबट्रॅक्ट करायचं असेल तर सबट्रॅक्ट करायचं, ॲड करायचं असेल तर ॲड करायचं. 4/3 + 1, फक्त 1च बरं का, 2 3 4 5 नाही, 1 जेव्हा ॲड करायचं आहे. 4/3 + 1, 4मध्ये 3 ॲड करा, 4 + 3 किती येतं 7/3. आता सांगा मला ddx ऑफ 1/x to the power 5/4 काय येईल, -n मीन्स -5/4, x to the power 5 + 4 किती 9, 9/4. व्हेरी सिम्पल. इथे 8 अगेन ddx ऑफ 1/x to the power 3/5. चला सांगा, -n मीन्स -3/5, x to the power 3 + 5 8, 8/5. व्हेरी सिम्पल. ddx ऑफ 1/x to the power 4/9 काय येईल, -4/9 x to the power डिनॉमिनेटरमध्ये 4 + 9, 4 + 9 मीन्स 13. Right? In this way, 10 suppose, again ddx of 1/x to the power 7/3. Right? Again -7/3 x to the power 7 + 3 10, 10/3. Right? But here your function, it is in the denominator. वर x to the power n, खाली x to the power n. हे लक्षात ठेवा. याला कृपया वर नेऊ नका आणि वर नेऊन मायनस करू नका, मायनस इंडेक्स करू नका, कारण आपण हा वेगळा फॉर्म्युला इथे शिकवलेला आहे. 1/x to the power n म्हणजे -n डिवायडेड बाय x to the power n+1. मुलं इन प्रॅक्टिस करताना परत याला वर नेतात, म्हणजे x to the power -2 करून करतात. तर तसं न करता ह्या डायरेक्ट पद्धतीने तुम्हाला करता येतो. सो यू हॅव टू रिमेंबर द 2 फॉर्म्युलीज, व्हेरी व्हेरी इम्पॉर्टंट. x to the power n and 1/x to the power n, isn't it? Now see here, the problem of the addition, isn't it? The derivative of a function when the so many functions are added. I will take one simple example here. Y is equal to 2 sin x, x to the power 3/2, 4 cos x, 5 e to the power x plus log x plus 1 upon x to the power 3 minus or plus here 3 sec x, again plus 4 cosec x and plus 5 cot x. See here 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 functions addition hai. You can easily find out. See here, take one by one derivative dy by dx. Means what here? ddx of y. Means y is, how many functions are there? Total 9 functions. Therefore first 2 remain as it is. Take ddx of sin x. Right? Again ddx of x to the power 3 by 2. Again, when the constant, it is multiplied to the function, constant remain as it is, take ddx of cos x. Right? Plus 5 remain as it is. Again, take ddx of e raised to x. Again, ddx of log x. ddx of 1 upon x to the power 3. Again, 3 remain as it is. When the constant, it is multiplied to the function, constant remain as it is, take ddx of sec x. Plus 4 remain as it is, ddx of cosec x. Right? Again, 5 remain as it is, take ddx of cot x. See here. Here again, 5 remain as it is, ddx of cot x. Right? So, 2 sin x derivative cos x. Again power formula. Power it is multiplied 3 by 2. X to the power n minus 1 means 3 minus 2 1 by 2. 4 remain as it is. Cos x derivative minus sin x. हे ब्रॅकेट मध्ये लिहायचं. मुलं असं लिहितात 4 minus sin x. This is wrong. 4 मधून sin x सबट्रॅक्ट करतोय का आपण? नाही. 4 into minus sin x. Therefore this you have to write in what here? Bracket. Bracket मध्ये लिहा. Right? Again 5 remain as it is. E to the power x derivative e to the power x. Again the derivative of a log x, that is 1 by x. Again 1 upon x to the power 3. Right? Again the power it is in the denominator. What is the formula? Minus n divided by x to the power n plus 1. Means minus n means minus 3 divided by x to the power 3 plus 1 means 4. Again 3 remain as it is. What is the derivative of sec x? Sec x into tan x. Right? 4 remain as it is. What is the derivative of a cosec x? Minus cosec x into cot x. Right? And again 5 remain as it is. What is the derivative of a cot x? Minus cosec square x. Right? Here you have to write plus into minus minus. Here also you have to write plus into minus minus and then simplify. In this way you can find out the derivative of a functions when the 2 or more than 2 functions are get added. Isn't it? So I have added the 9 function. कितीही फंक्शनचे तुम्ही या पद्धतीने डेरिव्हेटिव्ह काढू शकता. Right? But you should know all the formulas. Right? First by heart the formulas. The 15 formulas you should know. Isn't it? Then and only then you can perform the problem. You can do the problem very well. But the formula must be you know. Isn't it? Each and every formula. झोपेतून उठून विचारलं तरी आला पाहिजे. एवढे ते महत्त्वाचे आहेत. प्रत्येक फॉर्म्युला तुम्हाला केव्हाही विचारला तर आला पाहिजे तरच तुम्ही फटाफट प्रॉब्लेम करू शकता. राईट? नाउ सेकंड वन हियर. सपोज आय टेक सी लाईक दिस. सिंपल वन. Second one, y is equal to root x, 3x root x, 4x square root x. You can take minus sign also, 5x cube root x. Here again, plus, see, itparantच घेऊया. Right? Now again if you observe this, root x derivative तुम्हाला डायरेक्ट काढता येते. That is 1 upon 2 root x. What is the derivative of a root x? 1 upon 2 root x. पण x रूट x जर काढायचं असेल तर हिअर डोंट अप्लाय मल्टिप्लिकेशन रूल. इथे तुम्ही मल्टिप्लिकेशन रूल अप्लाय करू शकत नाही. बिकॉज दिस इज एक्स टर्म. दिस इज ऑल्सो द टर्म ऑफ ए एक्स बट दिस इज इन द फॉर्म ऑफ ए रूट. एक्सच फंक्शन आहे. दुसरं आहे का, वाय आहे का, एम आहे का, दुसरं काही नाही आहे, कॉन्स्टंट आहे का, नाही, राईट. पण हा एक्स रूटमध्ये आहे आणि हा एक्स बाहेर आहे. या एक्सचा पॉवर किती आहे, 1, आणि याला रूटच्या जर बाहेर काढलं तर या एक्सचा पॉवर किती येतो, 1/2. नाउ वेन द बेस इज सेम यू कॅन ॲड द इंडायसेस एक्स टू द पॉवर एम आणि एक्स टू द पॉवर एन असं जर असेल देन यू कॅन राईट एक्स टू द पॉवर एम प्लस एन. दिस इज द लॉज ऑफ इंडायसेस, isn't it? So when the base is same you can add indices, therefore here you can add the indices 1 plus 1/2 that is equal to x to the power 3/2, isn't it? Therefore x into root x, always x to the power 3/2. Again see here x square root x, right? This is x square and what is the power of this x, that is 1/2, means 2 plus 1/2. See here 2 plus 1/2, 2 to the 4, 4 plus 1 5, म्हणजे काय येईल 5/2, राईट. असं असेल एक्स क्यूब रूट एक्स. अगेन सी एक्स क्यूब आणि एक्सचा पॉवर 1/2. अगेन 3 plus 1/2, 3 to the 6, 6 plus 1 7/2, एक्स टू द पॉवर 7/2. एक्स टू द पॉवर 4 रूट एक्स. अगेन सी एक्स टू द पॉवर 4, एक्स टू द पॉवर 1/2, 4 to the 8, 8 plus 1 9, means x to the power 9/2, isn't it? X to the power 5 root x. Again x to the power 5, x to the power 1/2. Again 5/2, 5 2s are 10, 10 plus 1 11, 11/2, right? Therefore remember here x into root x, x to the power 3/2, x square into root x, x to the power 5/2, x cube root x, x to the power 7/2, x to the power 4 root x, x to the power 9/2, x to the power 5 into root x, x to the power 11/2, isn't it? Always remember this, and first you have to simplify this and then and only then you have to find out the derivative. root x ला करण्याची गरज नाही, कारण root x चे डेरिव्हेटिव्ह तुम्ही डायरेक्ट फाइंड आउट करू शकता, right? Here therefore you have to be very careful whenever the term like this, that is x into root x, x square into root x, first you have to simplify that function, that is this is root x, this is x, 1 plus 1/2 3/2, 4, 2 plus 1/2 5/2, again minus 5, 3 plus 1/2 7/2, right? Now dy by dx, right? ddx of root x, 3 remain as it is, ddx of x to the power 3/2, 4 remain as it is, ddx of 5/2, minus 5 remain as it is, ddx of x to the power 7/2. गॉट इट? जर अशा टाईपचे फंक्शन असेल तर तिथे मल्टिप्लिकेशन रूल अप्लाय करायचा नाही, पहिले एक्सचा पॉवर नीट करून घ्यायचा. हा 2 आहे, हा 1/2 आहे. वेन द बेस इज सेम यू कॅन ॲड द इंडायसेस. आता आपले पॉवर सगळे व्यवस्थित आले. 1/1 आपण डेरिव्हेटिव्ह काढू. रूट एक्सचे डेरिव्हेटिव्ह 1/2 रूट एक्स. हिअर 3 रिमेन ॲज इट इज. अगेन x to the power n ची डेरिव्हेटिव्ह n into x to the power n minus 1 means 3/2 into x to the power 3 minus 2 किती 1/2. अगेन 4 power multiplied 5/2 x to the power 5 minus 2 3/2 minus 5 again 7/2 x to the power 7 minus 2 5/2, right? See 1/2 root x. सिम्प्लिफाय करा 9/2 x to the power 1/2, again 2 2s are 4, 5 2s are 10, x to the power 3/2, 7 5s are 35, 35 divided by 2 x to the power 5/2. This is the derivative, isn't it? Therefore if there is a addition of so many function, then what you have to do, first you have to make the power here, that is x आणि रूट एक्स यांचा पॉवर एकत्र करायचा आणि नंतरच डेरिव्हेटिव्ह काढायचे. त्यानंतर थर्ड एक्झाम्पल आय विल टेक हिअर, दॅट इज ऑन ॲडिशन ओनली. सी थर्ड एक्झाम्पल, सपोज y इज इक्वल टू 1/x, 2/x स्क्वेअर, 3/x क्यूब, 4/x to the power 4, 5 divided by x to the power 5. अगेन व्हेरी सिम्पल. इथे पॉवर कुठे दिसायला आहे तुम्हाला? खाली दिसायला. पॉवर कुठे दिसतंय? खाली दिसतंय. म्हणजे कुठला फॉर्म्युला यूज करायचा? 1/x to the power n. What is the formula? Minus n divided by x to the power n plus 1. Remember this, minus n divided by x to the power n plus 1. Say dy by dx. Again, d dx of 1 by x. 2 remain as it is. d dx of 1 upon x square. 3 remain as it is. d dx of 1 upon x cube. 4 remain as it is. d dx of 1 upon x to the power 4 आणि plus 5 remain as it is. d dx of 1 upon x to the power 5. राईट, असं लिहायचं व्यवस्थित प्रत्येक स्टेप, तरच तुम्हाला येईल. मायनस एन, व्हॉट इज द पॉवर 1? मायनस एन मीन्स मायनस 1 डिवायडेड बाय एक्स टू द पॉवर 1 प्लस 1 मीन्स 2. अगेन 2. व्हॉट इज द पॉवर 2? मायनस एन मीन्स मायनस 2 divided by x to the power 3. Again 3. Again power is 3. Minus 3 divided by x to the power n plus 1 means here 4. Again 4. Minus n means minus 4 divided by x to the power 5. Again 5. Minus 5 divided by x to the power 6. Now simplify the function. Here minus 1 upon x square. Here minus 4 divided by x cube. Minus 9 divided by x to the power 4, minus 16 divided by x to the power 5, and minus 25 divided by x to the power 6. Right? In this way, if the power it is in the denominator, if your function it is in the denominator, then you have to use the formula 1 upon x to the power n. Don't take in the numerator. लक्षात ठेवा strictly. न्यूमरेटरमध्ये अजिबात न्यायचं नाही, त्याला मायनस करायचं नाही. हाच फॉर्म्युला यूज करायचा 1 अपॉन एक्स टू द पॉवर एनचा, दॅट इज मायनस एन डिवायडेड बाय एक्स टू द पॉवर एन प्लस. ठीक आहे, आले लक्षात? राईट. अगेन आय विल टेक वन मोर प्रॉब्लेम. सी, सपोज y इज इक्वल टू 1 upon root x, 2 divided by x root x, 3 divided by x square root x, 4 divided by x cube root x. Right? See, again, what you have to do? Again you have to make the power. See, here x into root x. आत्ताच सांगितलं तुम्हाला, या x चा पॉवर किती 1/2. या x चा पॉवर किती, इथे x चा पॉवर 1 आणि हा 1/2. मग 1 plus 1/2 3/2, परत 3, 2 plus 1/2 5/2, 4, 3 plus 1/2, 3 2 is 6, 6 plus 1 7/2. Right? Again dy by dx. Here minus n means minus 1/2. एक minute. Say, take d dx of 1 upon x to the power 1/2. 2 remain as it is. d dx of 1 upon x to the power 3/2. 3 remain as it is. d dx of 1 upon x to the power 5/2. Again 4 remain as it is. d dx of 1 upon x to the power 7/2. Right? See, minus n means minus 1/2. x to the power n plus 1. आता n plus 1 म्हणजे काय सांगितलं तुम्हाला? त्याच्यामध्ये न्यूमरेटरमध्ये हा डिनॉमिनेटर ॲड करा. 1 plus 2 3 3/2. राईट. अगेन 2 रिमेन ॲज इट इज. मायनस एन मीन्स मायनस 3/2 एक्स टू द पॉवर. 3 plus 2 मीन्स 5/2. राईट. अगेन 3. मायनस एन मीन्स मायनस 5/2 एक्स टू द पॉवर. 5 plus 2 7/2. अगेन 4. मायनस 7/2 x to the power 7 plus 2 9/2. Right? Now simplify this. 1 upon इथे x to the power 3/2. Here again 2 to get cancel. Here minus 3 divided by x to the power 5/2. This is 3 into minus 5 means minus 15 divided by x to the power 7/2. 2 2 is 4. Again minus 14 divided by x to the power 9/2. राईट. अगेन इन दिस वे. इथेच सगळे कन्फ्यूज होतात. खाली पॉवर वर पॉवर, खाली पॉवर वर पॉवर. आणि रूटमध्ये जर पॉवर असेल असा एक्स इंटू रूट एक्स एक्स स्क्वेअर, इथे सगळे कन्फ्यूज होतात, उगाचच मल्टिप्लिकेशन वगैरे रूल अप्लाय करतात. सो हिअर यू हॅव टू बी व्हेरी केअरफुल, isn't it? Again, the last example I will take, fifth one. Say here x root x 1 upon x square root x 2x square root x 3 divided by x cube root x. Take this problem. आता जर बघितलं तुम्ही, एकदा वर पॉवर आहे, एकदा खाली पॉवर आहे. इथे पण मुलं कन्फ्यूज होतात. नो वाय इज इक्वल टू से पॉवर 1 1/2 मीन्स एक्स टू द पॉवर 3/2. हिअर अगेन 1 अपॉन 2 2 plus 1/2 2 2 is 4 x to the power 5/2. Right? Again 2 2 plus 1/2 2 2 is 4 5/2. Again 3 3 plus 1/2 3 2 is 6 6 plus 1 7/2 x to the power 7/2. Now again you have to take the derivative of every function. dy by dx ddx of x to the power 3/2 ddx of 1 upon x to the power 5/2. 2 remain as it is. ddx of x to the power 5/2 and 3 remain as it is. ddx of 1 upon x to the power 7/2. See. Again, वर पॉवर आहे, पॉवर मल्टिप्लाइड 3/2, पॉवरमधनं एक सबट्रॅक्ट 3 - 2 1/2. पॉवर खाली आहे मायनस एन मीन्स -5/2 एक्स टू द पॉवर, एक इथे ॲड करायचं 5 + 2 7/2. राईट. अगेन 2 रिमेन ॲज इट इज. वर पॉवर आहे अगेन 5/2 एक्स टू द पॉवर n + 1 n - 1 मीन्स 5 - 2 किती येतं 3/2. पॉवर इट इज मल्टिप्लाय आणि पॉवरमधनं एक सबट्रॅक्ट. आता इथे परत खाली पॉवर आहे -n मीन्स -7/2 एक्स टू द पॉवर 7 + 2 9/2. राईट. खाली पॉवर वर पॉवर, खाली पॉवर वर पॉवर. राईट. इथे पॉवर 3/2 मीन्स 3/2 एक्स टू द पॉवर 3 - 2 1/2. इथे खाली पॉवर आहे मीन्स -n मीन्स -5/2 एक्स टू द पॉवर 5 + 2 7/2. राईट. परत 2 रिमेन ॲज इट इज. आता वर पॉवर आहे n इंटू एक्स टू द पॉवर n - 1 मीन्स 5/2 एक्स टू द पॉवर 5 - 2 मीन्स 3/2. परत खाली पॉवर आहे 3 -n मीन्स -7/2 एक्स टू द पॉवर n + 1 मीन्स 7/2 + 1 मीन्स 7 + 2 9/2. नाउ सिम्प्लिफाय 3/2 एक्स टू द पॉवर 1/2 -5/2 x to the power 7/2 2 to get cancelled 5 x to the power 3/2 minus 21 divided by 2 x to the power 9/2. This is the result, and this is about the derivative of the function when the two or more than two functions are added. Now the problem on product rule. See the product rule. What is the product rule? ddx of u into v, it is equal to u remain as it is, take the derivative of a second term plus second term remain as it is, take the derivative of a first term. Right. Now take the simple example. ddx of x into sin x. Right. Again see x into sin x. There are the two functions. You have to apply the product rule, isn't it? Again x remain as it is. ddx of sin x plus sin x remain as it is. ddx of x. Right. So the first term remain as it is, take the derivative of a second term, plus second term remain as it is, take the derivative of a first term. X remain as it is. Sin x, the derivative of a sin x, that is cos x, plus sin x remain as it is, and the derivative of a x, that is equal to 1. Very simple. Second example, suppose I consider ddx of x square log x, isn't it? Again x square remain as it is. ddx of log x plus log x remain as it is. ddx of x square. right? Again, x square remain as it is. The derivative of a log x, that is nothing but 1 by x, plus log x remain as it is. Again, the derivative of a x square, that is equal to 2x. Isn't it? Again, 1x get cancelled. What is remain? X plus log x into 2x. Very simple examples are there. Suppose I consider the third example, ddx of root x into e to the power x. Right? Again see, root x remain as it is, ddx of e raised to x plus e raised to x remain as it is, ddx of root x. Root x remain as it is. The derivative of e to the power x, that is e to the power x. E raised to x remain as it is, and the derivative of a root x, that is equal to 1 upon 2 root x. Isn't it? In this way, we can apply the product rule. If there is a product of a two function, then strictly you have to apply the product rule. In the product rule, the first function remain as it is. Take the derivative of a second function, give the plus sign. Again, second function remain as it is, and take the derivative of a second function. Isn't it? So in this way, you can do this. Again, I will take more problem here. See. Suppose the problem is like this. Fourth one, y is equal to x to the power 4 by 3, and here cosec x minus cot x. Now see again, how will you do this? Dy by dx means d dx of, what is your y? X to the power 4 by 3 into cosec x minus cot x. Right? See, there are the two functions. First one is the x to the power 4 by 3. Second one is the cosec x minus cot x. Isn't it? So, x to the power 4 by 3 remain as it is. Take d dx of cosec x minus cot x plus cosec x minus cot x remain as it is, d dx of x to the power 4 by 3. Right? Now see here again, x to the power 4 by 3. Here again you have to apply the subtraction rule. Here you have to take the derivative of a cosec x as well as the cot x. What is the derivative of a cosec x? Minus cosec x into cot x. And what is the derivative of a cot x? Minus cosec square x. This minus, that minus, minus minus plus cosec square x. Isn't it? So, the derivative of a cot x, that is minus cosec square x, this minus and that minus, minus minus plus. Again, cosec x minus cot x remain as it is, and the derivative of a x to the power 4 by 3, again you have to use the power formula, 4 by 3, x to the power 4 minus 3 means 1 by 3. Right? Now again, if you observe this, here x to the power 4 by 3, from this you can take cosec x common. If you take cosec x common in this bracket, what is remain? See, cosec x जर common काढलं, then you will get minus cot x plus cosec x. Again plus cosec x minus cot x remain as it is, and here 4 by 3 x to the power 1 by 3. Again, if you observe this, the bracket you can take common, that is cosec x minus cot x. Here also cosec x minus cot x. And again, x to the power 1 by 3 also you can take common, because this, suppose you take x to the power 1 by 3 common, you can subtract 1 by 3 from what here 4 by 3. Isn't it? Therefore, take common cosec x minus cot x and into x to the power 1 by 3. Right? When you take anything common, then you have to divide it with this term to the internal term. ज्या काय आतमध्ये terms आहे, whatever the terms in bracket, you have to divide it with this, isn't it? Therefore, cosec x minus cot x get cancelled. What is remain? Cosec x. Right? And again, when you divide it to x to the power 4 by 3 by x to the power 1 by 3, see, x to the power 4 by 3 divided by x to the power 1 by 3. Now you can take this term in the numerator, x to the power 4 by 3, x to the power minus 1 by 3. Again the base is same. you can add indices. 4 by 3 minus 1 by 3, you will get 4 by 3 minus 1 by 3, 3 by 3. 3 by 3 get cancelled. What is remain? X. Therefore, whenever you take cosec x minus cot x common and x to the power 1 by 3 common, then what is remain here? This cosec x, and here you what is remain? Only x. Right, because x to the power 3 by 3, 3 get cancel, and what is remain? X. Right, again see here cosec x minus cot x again common, x to the power 1 by 3 get common, plus what is remain? 4 by 3. This is the result, isn't it? So this is about the product rule. Again I will take some more problem here. Say the fifth one, I will take here x cot x and x root x tan x. Right? Now though this is the addition, but here there is a multiplication, here also there is a multiplication. See what you have to do. Again dy by dx, it is nothing but ddx of x into cot x plus ddx of x root x into tan x. Right? Now before that, what you have to do? First you have to simplify the function ddx of x into cot x, but here you have to write, see, in the first video I have told you that is x root x. See, x root x, that is nothing but the power of x, that is equal to 1, and here x to the power 1 by 2. Therefore here x to the power 1 and x to the power 1 by 2, base is same, you can add indices. Therefore x to the power 3 by 2 into tan x. Now apply the multiplication rule. First you have to apply the addition rule here. Now apply the multiplication rule. See here, the multiplication rule. Again x remain as it is, ddx of cot x plus cot x remain as it is, ddx of x. Right? Now again say x to the power 3 by 2 remain as it is, ddx of tan x. Here also you have to apply multiplication rule. Tan x remain as it is, and ddx of x to the power 3 by 2. Right? Now see x. What is the derivative of a cot x? The derivative of a cot x, that is minus cosec square x. Right? Plus cot x remain as it is, and the derivative of a x, that is equal to 1. X to the power 3 by 2 remain as it is, the derivative of a tan x, that is equal to sec square x. Right? Plus tan x remain as it is, and the derivative of a x to the power 3 by 2, again the power formula, power it is multiplied, and you have to subtract 1 from the power. 3 by 2 minus 1 means 3 minus 2, that is equal to 1 by 2. Right? In this way you have to apply the product rule. Right? X cot x plus x root x into tan x. This you have to convert in the form of a power. याला power में convert करना चाहिए यहाँ. X to the power 3 by 2 first you have to write, and into tan x, isn't it? So here you have to apply the multiplication rule, again give the plus sign, and again apply the multiplication rule. Right? Again I will take another problem. This is the fourth one. I will take fifth one here again. See, fifth one, y is equal to e raised to x sin x into log x. Here again if you observe this, there are how many functions are there? 3 functions are there, isn't it? U, V, W. Again what you have to do? Apply the multiplication rule, but whenever the 3 function get multiplied, I have told you the rule of the derivative, that is first you have to keep this 2 function as it is, take the derivative of a third function. Then you have to keep the second function and third function as it is, take the derivative of a first function, plus again the first and the third function remain as it is, take the derivative of a middle function, isn't it? Therefore dy by dx, here again e raised to x sin x remain as it is, take ddx of log x plus sin x log x remain as it is, ddx of e raised to x, right? Plus again e raised to x log x remain as it is, ddx of sine x. Right? Now see, e raised to x sine x remain as it is. What is the derivative of a log x? That is equal to 1 by x plus sine x log x remain as it is. What is the derivative of e to the power x? E to the power x. Right? E raised to x log x remain as it is, and what is the derivative of a sin x? That is equal to cos x. Isn't it? In this way you can do such a problem here, that is when the three functions get multiplied. How will you do this? The first two functions remain as it is, e raised to x sin x remain as it is, take the derivative of a log x, plus second function, third function, that is sin x log x remain as it is, take the derivative of a first function e to the power x, plus first function and the third function remain as it is, take the derivative of a middle one, e raised to x sin x remain as it is, the derivative of a log x, that is equal to 1 by x, sin x log x remain as it is, e to the power x, the derivative of a e to the power x, that is e to the power x, plus e to the power x into log x remain as it is, the ddx of sin x, that is equal to cos x. Right? Sixth one again, y is equal to, suppose, x plus 1, x plus 2 and x plus 3. Again the three functions get multiplied. See how will you do this? Dy by dx. Here again the two bracket, that is remain as it is, take the derivative of a third function. Again second and third function remain as it is, take the derivative of a first. Again first and third remain as it is, take the derivative of a second function. Now here x plus 1, x plus 2 remain as it is, ddx of x plus 3 plus x plus 2, x plus 3 remain as it is, take the derivative of a x plus 1, right, plus x plus 1, x plus 3 remain as it is, take the derivative of a x plus 2. Right? Here again x plus 1, x plus 2 remain as it is, the derivative of a x 1, the derivative of a 3 0, 1 plus 0, that is always equal to 1. Therefore no need to write anything. 1 जरी लिहिला तरी याला काही फरक पडतो का? If you write 1 then there is a no difference, isn't it? Again x plus 2, x plus 3 remain as it is, derivative of a x1 and the derivative of a 1 0, therefore again 1 plus 0, that is equal to 1. No need to write 1, isn't it? Again x plus 1, x plus 3. See here, the derivative of a x1 and the derivative of a 2, that is 0, 1 plus 0, again 1, right? Now you can multiply the bracket. See, how will you multiply? X into x, x square. Then what you have to do? You have to add this 2 and 1. 2 plus 1, what here? 3, and write down 3x, isn't it? In this way you can multiply x into x, x square. Then make the addition of this, plus 2 plus 1 means that is equal to 3, and write here x, isn't it? 3x, and 1 into 2, 2, right? In this way you can make the multiplication. X into x, x square, 3 plus 2, that is 5, means 5x you have to write, 3 2s are 6, right? Again x into x, x square, 1 plus 3 4, 4x, and 1 into 3, that is equal to 3, right? X square, x square, x square, you have got as a 3x square. 3x plus 5x plus 4x, 3x plus 5x, 8x, 8x plus 4x, 12x, right? 2 plus 6, 8, 8 plus 3, that is equal to 11, isn't it? Therefore the result is 3x square plus 12x plus 11, isn't it? 6 plus 3, that is equal to 9, and 9 plus 2, that is equal to 11. In this way you can apply the multiplication rule, right? Again I will take the more problem here. See the multiplication rule. Seventh one, y is equal to 2x plus 3, 4x minus 5, right? Again see how will you do this? Dy by dx. Again there is a multiplication of a 2 bracket. 2x plus 3 remain as it is, take derivative of a 4x minus 5, right? Plus 4x minus 5 remain as it is, ddx of 2x plus 3. Right? First bracket remain as it is, take the derivative of a second one, plus second bracket remain as it is, take the derivative of a first one, isn't it? Again 2x plus 3, the derivative of a 4x, that is equal to 4. 4 remain as it is. When the constant, it is multiplied to the function, constant remain as it is. The derivative of a x, that is equal to 1. Therefore 4 into 1, that is 4, and the derivative of a 5, simple constant here, simply constant here, therefore the derivative, it is equal to 0. Again 4x minus 5 remain as it is. Again the derivative of a 2x, that is always equal to 2. Remember, the derivative of a x 1, derivative of a 2x 2, derivative of a 3x 3, derivative of a 4x 4, derivative of a 5x 5. Because 5 remain as it is, the derivative of x, that is always equal to 1. When the constant, it is multiplied to the function, constant remain as it is, and take the derivative of a function. Very simple. Now multiply with 4 to this bracket and open the bracket. 4 2 is 8, 4 3 is 12, again 4 2 is 8, and 5 2 is 10. Right? 8x plus 8x, that is equal to 16x, 12 minus 10, that is equal to 2. Right? Therefore here you have got dy by dx, it is nothing but 16x plus 2. Right? So this is the product rule, and this is the multiplication of a 2 function. Again another problem, see, 8th one, y is equal to 2x square plus 3 and 5x square minus 4. See, the same rule you have to apply, dy by dx. Here 2x square plus 3 remain as it is, ddx of 5x square minus 4. Right? Plus 5x square minus 4 remain as it is, ddx of 2x square plus 3. One bracket remain as it is, take the derivative of another bracket, plus another bracket remain as it is, take the derivative of a first bracket, isn't it? Now here 2x square plus 3 remain as it is, the derivative of a 5x square, again 5 remain as it is. Here you have to apply the power formula, power it is multiplied, and you have to subtract from the power, means the derivative of a x square, that is equal to 2x. Means the derivative of a 5x square, that is nothing but what here, 10x. Therefore directly I write 10x. And the derivative of a minus 4, that is always equal to 0, because this is the constant, and the derivative of a constant function, it is always equal to 0. 5x square minus 4 remain as it is, and here again 2 remain as it is. The derivative of a x square, that is 2x. 2 into 2x, it is nothing but what here, 4x. Therefore the derivative of a 2x square, that is equal to 4x, and the derivative of a 3, that is 0. Right? Now multiply with 10x. 10x into 2, that is equal to 20x cube. 10 into 2, 20. X square into x, x cube. Right? Again 10 into 3, that is equal to 30x. Again 5x square into 4x, that is equal to 20x cube. Right? 5 4s are 20, x square into x, that is equal to x cube, minus 4 into 4x, that is equal to 16x. Again 20x cube, 20x cube, you have got as a 40x cube, and 30x minus 16x, you have got as a 10 minus 6, that is equal to 4, and here 3 minus 2, that is equal to 1, 14x. 30x minus 16x, that is equal to 14x. This is about the product rule, isn't it? So here we have studied about the product rule. Whenever there is a multiplication of a 2 function or 3 function, then you have to apply the product rule. Right? One function remain as it is, take the derivative of another function. First another plus another function remain as it is, and take the derivative of a first function, isn't it? These are the sufficient for the product rule. These problems are sufficient for the product rule, isn't it? Now I will take the division rule. See, division rule. Division rule. That is ddx of u by v. Whenever the two functions are in the form of a division, in the form of a quotient, then how will you differentiate, isn't it? How will you find out the derivative, right? So again, the denominator remain as it is, v remain as it is. Take the derivative of a u minus the numerator remain as it is. Take the derivative of a denominator, dv divided by dx divided by v square, isn't it? Where v not equal to 0, isn't it? So the denominator remain as it is. Take the derivative of a numerator minus numerator remain as it is. Take the derivative of a denominator divided by denominator square, right? One simple example I will take. Y is equal to 5x plus 3 divided by 3x plus 2, isn't it? This is a one simple example. Now see what you have to do. Dy by dx. It is nothing but, what is the denominator? 3x plus 2. 3x plus 2 remain as it is. Take ddx of 5x plus 3, right? Minus 5x plus 3 remain as it is. ddx of 3x plus 2 divided by 3x plus 2 whole square, right? See, how will you apply the formula here? The denominator remain as it is. Strictly take the derivative of a numerator. यहाँ numerator के derivative लेना. First you have to keep the denominator remain as it is. यहाँ you can substitute the denominator remain as it is. Take the derivative of a numerator minus numerator remain as it is. Take the derivative of a denominator divided by denominator square. क्या कर रहे हैं अपन? डिनोमिनेटर को एज इट इज रख रहे हैं. बाद में you have to take the derivative of a numerator. We have to give the minus sign here. Again, we have to keep the numerator remain as it is. Take the derivative of a denominator and divide it by denominator square, right? Say 3x plus 2. क्या है इसके डेरिवेटिव? 5x के डेरिवेटिव 5 माइनस 5x plus 3 remain as it is. What is the derivative of a 3x? 3x के डेरिवेटिव क्या है? 3. 2 की 0, 3 की 0 divided by 3x plus 2 whole square, right? Now you have to multiply with 5 to this bracket and open the bracket, isn't it? 5 into 3, 15x. 5 2s are 10. Give the minus sign, remain as it is. Multiply with 3. 3 into 5x, 15x. 3 into 3, 9. Divided by 3x plus 2 whole square, right? Again 15x plus 10. Multiply with minus sign and open the bracket. Minus 15x minus 9 divided by 3x plus 2 whole square, isn't it? 15x get cancelled. 10 minus 9, that is equal to 1. 1 divided by 3x plus 2 whole square, isn't it? So this is about the division rule, right? Whenever your function it is in a quotient form, you have to apply the division rule. Denominator remain as it is. Take the derivative of a numerator minus numerator remain as it is. Take the derivative of a denominator divided by denominator square, isn't it? Again, the another problem, see. Second one, suppose I write like this problem, that is ax plus b divided by cx plus d. If I do this problem, you will get the formula, because a, b, c and d, these are the any constant. Suppose you know the formula, you can substitute only the values, that is a, b, c and d, isn't it? So here you have got the formula, you will get the formula. See again how will you do this? Again dy by dx. Denominator remain as it is. Cx plus d remain as it is. ddx of ax plus b. Take the derivative of a numerator minus numerator remain as it is. Take the derivative of a denominator ddx of cx plus d, right? Divided by cx plus d whole square, right? See here, cx plus d remain as it is. the derivative of a ax, that is always equal to a, because a is the constant. When the constant, it is multiplied to the function, constant remain as it is, and the derivative of a x, that is equal to 1. B again constant, what is the derivative of a b? That is equal to 0, right? Minus ax plus b remain as it is. The derivative of a cx, that's a 2x derivative 2, 3x 3, 4x 4, 10x 10, 100x 100. In the same way, the derivative of a cx, that is c, and the derivative of a d, that is always equal to 0, because that is the constant. Again, cx plus d whole square, right? Now see, multiply with a into cx, that is acx, a into d, that is ad. Again, multiply with c, right, and open the bracket here, minus, you have to multiply with c, that is acx and bc, divided by cx plus d whole square, right? Now here acx, this is ad, multiply with minus sign and open the bracket, acx minus bc divided by cx plus d whole square. Again, acx get cancelled, you have got ad minus bc divided by cx plus d whole square, right? Now if you know this formula very well, you can find out the direct answer. Suppose I consider the example, see here, simple example. Suppose y is equal to 2x plus 3 and 3x plus 4. Now here what is a? 2. What is b? 3. What is c? 3. What is d? 4. What is the result here? Dy by dx, it is equal to, what is the formula? AD. AD means what here? See, AD, 2 into 4, 8, right? BC, what is the formula here? That is AD minus BC. What is BC? 3 3s are 9, divided by, again, cx plus d whole square means 3x plus 4 whole square, right? Now 8 minus 9, that is equal to minus 1, divided by 3x plus 4 whole square. Directly you can do this, right? Suppose your function, it is like this, ax plus b divided by cx plus d, where a, b, c and d, these are the constant. And you have got the formula, that is ad minus bc, ad minus bc divided by cx plus d whole square, isn't it? Again, some simple problem. Suppose I take here y is equal to 5x minus 4 and 4 minus 3x, isn't it? Again, what is a? A is equal to 5. What is b? Minus 4. What is b? Minus 4. And here our formula is cx, that is ax plus b divided by cx plus d. This is cx plus d. Therefore, this is c, it is nothing but what here? Minus 3, and d, it is equal to 4, right? Now again, apply the same rule here. What is the rule here? Dy by dx. Directly you can find out, that is ad. What is ad? See here, 5 into 4, 20. Give the minus sign. What is bc? See here, bc, minus minus plus 4 3s are 12, right? Divided by cx plus d means 4 minus 3x whole square, right? 20 minus 12, that is 8, divided by 4 minus 3x whole square, right? By this short trick, you can do the any problem of the means such a type of a problem with the help of a division rule. This is the short trick, right? Now again, I will take another problem here. See, y is equal to log x divided by cos x, right? Again, dy by dx. Denominator remain as it is, cos x, ddx of log x, minus log x remain as it is, ddx of cos x, divided by cos square x, right? Cos x. What is the derivative of a log x? That is equal to 1 by x, minus log x remain as it is. What is the derivative of a cos x? Minus sin x, divided by cos square x, isn't it? Again, cos x divided by x minus minus plus log x into sin x divided by cos square x. Right? In this way, you can apply the division rule. There are so many problems, a different type of a problem. Therefore, I am going to try take the more and more problem so that the picture get clear. That is about the division rule. Again, I will take another problem here. Y is equal to, suppose, x sin x divided by log x. See this one, right? Again, dy by dx, it is equal to, denominator remain as it is, d dx of x sin x, take the derivative of a numerator, minus, numerator remain as it is, take d dx of log x divided by log x whole square. Right? Now see, log x as it is. Here you have to apply the multiplication rule because there is a x into sin x. Right? Apply the multiplication rule. See, x remain as it is. The derivative of a sin x, that is equal to cos x, plus sin x remain as it is, and the derivative of a x, that is equal to 1. Right? So don't forget this. Here you have to apply the multiplication rule. Log x remain as it is. The ddx of x sin x, that is equal to x remain as it is. The derivative of a sin x, that is cos x, plus sin x remain as it is, and the derivative of a x, that is equal to 1. Again, minus x sin x remain as it is, and the derivative of a log x, that is equal to 1 by x, divided by here log x whole square. Now multiply with this and open the bracket. This x get cancelled. Here you can multiply x log x cos x, right, plus log x into sin x. Right? Again, x get cancelled. What is remain? Sin x, and divided by log x whole square. This is the result. Right? This is about the division rule. Again, I will take more problem here. See, y is equal to sin x divided by 1 plus cos x. See this one. See again, dy by dx. Again, denominator 1 plus cos x remain as it is. d dx of sin x minus sin x remain as it is. d dx of 1 plus cos x divided by 1 plus cos x whole square. Right? Here 1 plus cos x remain as it is. Take the derivative of a sin x minus sin x remain as it is. Take the derivative of a 1 plus cos x divided by 1 plus cos x whole square. Right? 1 plus cos x. What is the derivative of a sin x? That is equal to cos x minus sin x remain as it is. The derivative of a 1, 0. And what is the derivative of a cos x? That is equal to minus sin x. So write minus sin x in bracket, isn't it? Divided by 1 plus cos x whole square. Right? Again, multiply with cos x. Cos x into 1 cos x. Cos x into cos x cos square x. This minus minus plus sin square x divided by 1 plus cos x whole square. Right? Now again, if you observe this, sin square x plus cos square x, that is equal to 1. Therefore here you have got cos x plus 1 divided by 1 plus cos x whole square. Now same term in the numerator, same term in the denominator get cancelled. Here 1 plus cos x, इथे सुद्धा 1 plus cos x whole square है. One term get cancelled. What is remain? 1 upon 1 plus cos x. Isn't it? So if you know the formula, that is, this is the evergreen formula, 1 plus cos x. It is nothing but what here? 2 cos square x by 2. Isn't it? Here I have given the name, that is the evergreen formula, 1 plus cos x, 1 plus cos 2x, 1 plus cos 3x, 1 plus cos 4x. You should know that is 1 plus cos x, it is equal to 2 cos square x by 2. Suppose I write like this, 1 upon 2 cos square x by 2. Then 1 by 2 remain as it is, and 1 upon cos square you can write as a sec square x by 2. Right? So this is the result, that is 1 upon 2 sec square x by 2. This is also one of the result. This is also the another result. So the another one here, say y is equal to 1 plus cos x, 1 minus cos x. Right? Say dy by dx. It is again 1 minus cos x ddx of 1 plus cos x. Denominator remain as it is. Take the derivative of a numerator, minus numerator remain as it is. Take the derivative of a denominator, that is 1 minus cos x, divided by 1 minus cos x whole square. Right? Say 1 minus cos x. The derivative of a 1, 0. What is the derivative of a cos x? That is equal to minus sin x. Right? Again, 1 plus cos x remain as it is. Again, the derivative of a 1, 0 and the derivative of a cos x, that is minus sin x. Minus minus plus sin x, isn't it? Divided by 1 minus cos x whole square. Say, you can multiply with minus sin x to this bracket and open the bracket. Minus sin x into 1 minus sin x. This minus 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 plus sin x into what here? Cos x. Again, multiply with sin x to this bracket and open the bracket. Minus sin remain as it is. Multiply with sin x. Sin x into 1 sin x. And plus sin x into cos x. Sin x into cos x. Divided by 1 minus cos x whole square. Right? Again, minus sin x into cos x. Multiply with minus sin and open the bracket. Minus sin x. Here plus into minus minus. Minus sin x cos x divided by 1 minus cos x whole square. Right? This get cancel. What is remains here? Minus sin x, that is equal to minus 2 sin x divided by 1 minus cos x whole square. Right? Here we have done the problem on what here? Division rule, isn't it? So this is about the division rule. So we have studied about the derivative of a addition rule, subtraction rule, multiplication and division. So here I have completed the problem, the many problems on what here? Addition, subtraction, multiplication and division, so that it's a very clear picture to you. And if you like this, like my video, then subscribe me, isn't it? And if any difficulty in this rule, then please give me the suggestion in my video and subscribe my channel.